horrible question, which got my guys here, which is asking us to find a surface integral, the curl one. The vector field is this, and the hemisphere we're talking about is this one here. Does it say anything else about it? It says it's a positive direction. That just means I don't need to worry about the sign unless I'm in. And if we work on this guy, it's kind of overlap from last time. Essentially, there's the x-axis. Here is the y-axis, and here is our z-axis. So the orientation of this shape is basically you have on the zy plane, we've got this guy, and then the hemisphere is coming outwards like that. So it's this way, right? Positive x, half a sphere, which is fine. Now, if you take that guy and you orientate the y and the z, you'll see that the region D that we're talking about is basically a circle. And if you look at the equation here and you rearrange it, it looks much more like what a sphere should look like. But when you take into account that, that's a y by the way, that is 0, what you're getting is a circle of radius 5. Now, the function that is the surface, right? In this case, we would typically call the surface g of xy, but in this case, I think it's more appropriate to call it g of yz, is essentially this guy here. I don't know, what's the easiest way to think about that? Can you imagine the z's and x? Wouldn't everything look much easier, right? So that might be a better way to actually turn this question on its head. You know, I could have started at the beginning and just said, x is z, y is y, and z is x, but we're committed to that, and that's fine. So we've got the surface, G. We know the region D. And we have a P, we have a Q, and we have an R. So if you want to find this fella, you're going to change it into a double integral over this circle of this expression using x, y, and z, dx, dy. I may have to change that to z actually, but that's fine. So I'll just call it a double integral. If you take this fella, which is negative e to the xy cosine z, and you differentiate it with this guy with respect to x, you get nothing, which is good news. You then take this guy and you differentiate this guy with respect to y. Oh, God in himmel. This guy with respect to y is going to be a mess. So if you call it 25, take away y squared, take away z squared to the half, you will get times 1/2, 25, take away y squared, take away y squared to -1/2, times a -2y. And then you do a plus r, which is xy. And that is going to be, in terms of right now, x and y. So we're going to do a double integral of, multiply this by this and this by this, you get, I believe, 2x squared yz times 25, take away y squared, take away z squared, call it dA. And there should be a -1/2 involved. And then you've got a plus xy. Nowhere in the world is that going to be pretty. But It is a y and a z guy, so I should at least be able to do that. Theta equals 0 to 2 pi. R equals 0 to 5. And I'm going to do a 2x squared yz all over a 25 take away y squared take away z squared to the half, plus an xy and dA. I'm keeping that d. Yes.
Why is there still a 2 in the numerator? Wouldn't it have canceled?
Cancelled out. It would. You're right. Good. I might actually stop my answer being 0. So I got to this point. I know that we're going to have to do some kind of situation here. This is normally xy, but because of the orientation, it's really going to be yz. And because it's going to be yz, that x squared is going to get taken out of here. So what we're going to do is square this guy. And a y and a z over square root of this guy. And that guy for the x. So we are looking at that expression. Just back to double integrals. Cancel, cancel. I get yz, the square root of 25 take away y squared take away z squared, plus a y, the square root of 25 take away y squared take away z squared. And we're still in y's and z's right now. Okay, we go into polar. The y is going to be our cos theta, and the z is going to be our sine theta. So I'm going to get an r cos theta times an r sine theta. And that guy is just the square root of 25 take away r squared. This guy is going to be r cos theta. Take away the square root of 25, take away r squared, finishing with another r dr d theta. Okay, I can pull out all sorts of stuff here. I think I probably should do it as two separate integrals. That guy times that guy times that guy gets me r cubed sine theta cosine theta, the square root of 25 take away r squared. And this one gets me an r squared cosine theta, the square root of 25 take away r squared. And then I just have a dr and a d theta. Is there any way to make this nicer? I'm going to go from theta equals 0 to theta equals 2 pi. And this one's going to go theta equal r equals 0 to r equals 5. They are separable. If I bring this one out, I'll have a cosine of theta starting at 0 and finishing at 2 pi with a whole load of stuff I don't care about. And the reason I don't care about it is because you can separate that out. And if you do this guy, you 0. So 0 times anybody still gets you 0. So see that horrible mess that is here and here? Right. These two guys, they won't matter because you'll get 0 times an integral I can't do, but 0 times an integral I can't do is still 0. Now, if you do the other one, which is this one up here, you're going to have theta equals 0 to 2 pi over sine theta cosine theta. And you're also going to have an r equals 0 to r equals 5 of a really ugly integral. If you do this integral, you will get 0. So I don't care what the ugly guy is, because 0 times an ugly guy is still 0, and 2 zeros give me an answer of 0. You want to check this out, but you can replace this as a half of sine 2 theta. And if you do an integral from 0 to 2 pi of a sine or a cosine or a sine 2 theta or a cosine 2 theta, all of those instances you end up with 0, because basically you end up with 1 take away 1, which cancels out, because the bit above is the same size as the bit below. So the ugly second part of this, right, these guys here, really didn't factor into it. In fact, I'm not even bothering to tell you what they are. I'm just saying squiggles, because I don't care what they are, because 0 times whatever you are is still 0. And that's a little bit of a cheat and a shortcut, but it's a lot easier than actually doing that integral. If I had to do that integral, wouldn't I have to do a u sub? And then after that u sub, I strongly suspect I would have some really ugly fractions. And then I multiply it by 0 and I still get 0. Are we cool with that, David? That is a massively ugly question. Oh, which bears me to tell you some things. I was originally going to do 15 questions for your final. And after I did 15 questions, I then pretend I'm a student and I do them. And then I add 50% because I typically do them quicker because I know what the answers are. And 15 was too much. So there's now 12 questions in your final. Just thought I'd tell you that. Everything else is basically what I said, it's still true, but there are fewer of them to do. I mean, take that last one. Can you imagine that last one would be a horrendously long question? You can't be expected to do that kind of question a lot, at least. Next topic.
Really quickly, someone asked in the chat if we can use squiggles on the final. Is that acceptable?
Squiggles on the final. Oh, I think I know what you mean. Do you know those kind of questions where you keep repeating yourself about 5 times and you're only changing one piece, right? So I'll make something up. Right, d theta, right, dr, whatever. And they said squiggles. How about 2 little dashes? And then whatever you're doing. And then 2 little dashes, whatever you're doing. Yeah, I would, as long as it's not too vague, I'd be fine. Or you could do just arrows.
So if it's like the one we just did, that would be acceptable?
Yes, and yeah.
Wonderful, thank you.
Because all you're doing is writing down something over and over and over again. And it's not changing, right? It's just an ugly expression that you're doing something else next to it. And then you're changing only one thing. So as long as you're changing only one thing, it's fine. I will be able to figure out what you're doing. Might save you a few minutes. Okay, where are we off to next? Is that my eyesight or is this not focused well? Can you read this? Okay. It looks blurred to me. I wonder if it's just my eyesight. Yeah, I get tough eyesight. Okay. Okay, let me throw a question out at you. Suppose I give you a function, a point, and a vector, and I asked you to find the directional vector at that point in this direction. So that fella. How'd you do it? How do you find directional derivatives? This happens just before Lagrange, if you're wondering where it is. So it's pretty early on. It's week 2.
I would start with the gradient vector, I think.
Right. And that is good, because if you started off with the gradient vector, you would get 2x take away 2y, and you would get negative 2x plus 3y squared. And if you didn't do anything except that, at least you've managed to get 4 points. So always think of, even if I don't know how to finish a question, I do know that it needs A, B, C, and D. So here's my next question. That guy is going to be involved in the answer. Do I do anything to that guy? Or can I use him as is?
Don't you have to square root them?
Could be a little bit more detail.
Turn it into a unit vector?
Yes. The devil is in the detail. Can I tell you, because I picked nice numbers, that the magnitude of that vector is 13. And when you do a directional derivative, don't you have to use a unit vector for the direction? Okay. Now, we got this guy, we got this guy. I need the next step.
You should be able to times your unit vector to your gradient vector.
So we call that times the dot product, but I know exactly what you mean, right? Oh, wait a minute. I still have some X's and Y's floating around. I want an answer 42, right? I want a number when I'm finished. So how do I get rid of the X's and Y's and get numbers?
Your points should be your X's and Y's.
Right. And by, yeah. You nailed it, right? Agreed? So what's that going to be? 2 times 1 take away 2 times 2, so that's negative 2. Negative 2 times 1 is negative 2, plus 12 gets me 10. So there's my guy. So I will be taking negative 2, 10, dot product with the unit vector of the direction. And that's going to get me negative 10 thirteenths minus 120 thirteenths to get me negative 130 thirteenths. So there's my directional vector. Now, do you see in that one question how many little pieces you kind of vaguely remember but don't always remember? Like, did some of you forget you needed a unit vector? Did some of you not remember that this guy needs to be turned into numbers by using the coordinates of this point? And that's the devil in the detail. Like, it's the details that catch you. You've got the general process, but if you get a bit rusty because you haven't done them for, what, 8 weeks, 2 months, you're not going to be as familiar. Now, there is another kind of question on this. You know, a question that says, in what direction is the maximum rate of change? What is the direction for the maximum rate of change? It's actually in front of us, if you know where to look.
It's the unit vector, right? 5 over 13, negative 12 over 13?
Nope.
Negative 2 over, or negative 2 and 10.
Yes. Isn't the gradient the guy that gives you the maximum rate of change. It essentially, isn't that the steepest part of the hill? Can you imagine the surface being a hill? So the maximum rate of change is, what direction should I go to make my life a misery? What's the steepest way up the hill or down the hill? I guess you could, depends on orientation. And if they asked you what would be the value of that maximum rate of change, so that guy there is the direction that you would go for the maximum rate of change, right? What's the value of the maximum rate of change?
I forget the name, but it's like the two lines where you do the square root of -2 squared plus 10 squared.
The word is magnitude, so you're right. So the magnitude of that would be what, 100, the square root of 104. And the last one is, what direction do you go, not for the maximum rate of change, but for no rate of change? In other words, kind of walking around the belly of the hill, right? So this guy is the maximum rate of change. What would be the minimum or zero rate of change? What vector would it be? What direction?
Isn't it the negative of that vector?
Kind of the reciprocal, right? Switch places. Which would be actually the vector that's orthogonal to it, right? So if you imagine with a hill and going this way would be the steepest, going that way would be the zero, right? It would be at right angles to the steepness. So if you just take the original vector and you switch places, won't that give you a dot product of zero? And you can make that vector as long or as short as you like. So it's also correct that that direction would be the smallest rate of change as well, because isn't it the same as that one, just half the size? So don't neglect the 40% of your questions that are going to come from the 5 weeks before the midterm.
Wouldn't the dot product of those two be like -40?
Oh, got to make one of them plus, you're right. The dot product should be zero. So switch them and make one negative is what you need to do. So show it again. If that was the maximum, switch them and make one of them negative. That one would count. So don't just switch them. Forgot to mention, although I did say that the dot product is zero, that you have to make the dot product zero. And so switching them will get you halfway there, right? But you have to make one of them change sign. So I decided to change that one because it's easiest. I could have changed the other one, couldn't I have? Wouldn't that one also count? Dot product zero. Right, switch places, but make this one negative. And if you're wondering what does that look like, well, aren't I just going that way? It's still perpendicular, but one's going to the left and the other is to the right. Okay, questions now. What you got for me? I'm on to my last piece of paper. You lot are costing me a fortune. Except I got this from the college, so yes, you're not. Next question.
How about a volume question? I remember running into that on the practice test.
Okay. A volume question, right. Hold on a minute. This should not be that hard. There. Just getting it a little bit separated. Okay, let's have a shape. let's have a, let's have a function surface. X squared minus 4e to the xy plus 1, right? And I would like to know the volume of this surface where the region D is described as a circle x squared plus y squared plus equals 1, right? So can you imagine that we have on the floor a circle, and above this circle there's a surface, and we want to find the volume of that weird shape, and the surface is going to be this guy here. So you can imagine there's some kind of surface along here. So if you move this up to the shape, can you imagine you might get a kind of distorted circle, and the volume we want is this really weird shape. Well, volumes of shapes like that are found by the double integral over the region D of the function dA. So in this case, it's going to be x squared minus 4e to the xy plus 1, and the region D, go there. And I'm going to have to stick an xy here, or else the question is not doable. So it's going to go r equals 0 to r equals 1 because it was a unit circle. And since it's a full circle, it's going to 0 to 2 pi. And so I'm going to do a polar. And x squared is going to become r squared cos squared theta. And this guy is going to become -4 sine theta, r sine theta, r cos theta. And this is going to be e to the r sine theta, r cos theta, plus 1. I'm regretting putting that e in there. It's too late now. So basically you're going to find the integral from 0 to 2 pi and from 0 to 1 of this guy, which is r cubed cos theta d theta. In the middle, you're going to get a 0 to 2 pi, 0 to 1 of -4 r cubed sine theta cosine theta e to the r squared sine theta cosine theta dr d theta. And at the end, you're just going to have a 0 to 2 pi, 0 to 1 of the function 1 dr d theta. And this horrible mess would probably come out with a u sub. Well, actually, we could separate it, but I wouldn't try, not with that power. So I would do a u sub, and then you get your answer. And this guy here would probably be best done by separating them. And this guy here is dead easy to do.
Shouldn't 1 be r?
Oh, okay. Okay. Oh, that's going to be even easier because that's going to get you a half r squared, which is a half, and half 2 pi. There, that guy's going to be pi. So, I don't know. 5 minutes on that, 10 minutes on that, nada pi. So you'd have somebody plus pi. And I don't think I should have put an e there in the first place, because normally don't you just get polynomials when you get these, just x squareds and y squareds, because they tend to play well. Different kind of volume question. Suppose I tell you x goes from 0 to 1, y goes from 0 to x, and z goes from x plus y to 10. So this is your region that you want to find the volume for. Well, in this question, x goes from 0 to 1, y goes from 0 to x, and z goes from x plus y to 10, and you just do 1 of dz, dy, dx. Are you comfortable that if your region is three-dimensional, the integral, the triple integral of 1 generates the volume of that region? Now, why did I do the variables in that order and not jumble them up in some other order? Why are z's first, y's second, and the x's last? Why is that the only reasonable order to do this triple integral?
Because if we do it in any other order, we're going to have leftover x's or y's, and we're not going to be able to integrate them.
Right. And you know that when you do it, without exception, isn't the last one has to be numbers, right? The third one. And if you look at these ones, don't you have the one with most variables first, the one with fewer variables second, and the one with none last? That would be your general rule for doing the order. I'm not doing that one. Would you agree? It's just messy, but you could do it. You get some various polynomials and you get the answer 42. What happens if I give you how do you approach the question, find the volume between two surfaces? So can you imagine you drew this surface and it looked like that? And then you drew the other surface and it looked like that. You're basically trying to find the volume of a peanut, aren't you? If that's what they look like. So we need to have a method for finding the volume. This is the most complicated of all the versions. So we need a strategy. First thing you do is you find the intersection of the two surfaces. Because what that is going to do, it's going to tell me the region in the bottom, because this thing here, right, is actually going to become a double integral. Now, if you take the first one, and I hope I've done this right, and you make it equal to, okay, I can fix this. I want to make a nice number if I can. That'll do. I'll make that 22 now. Okay, so we're going to have 22 take away 4x squared plus 2y squared. I want these guys to match up now. Yes, I do. There we go. Make that minus, make that minus. You should never make a question. You're seeing how I make questions up for exams. I play about with them till they work, right? So this is my second surface. Negative, negative, and a 22, right? This one I've left alone. If you add 4x squares to each side and you add 4y squares to both sides and you take away 6 from both sides, you get that. And that ends up being x squared plus y squared equals that guy. And that ends up being x squared plus y squared equals 8/3. Okay, it's not the best answer in the world, but do you see a circle radius root 8/3? And I'm not going to play about to try and make that number nice now. So you know the region, right? They intersect on a circle of radius 8/3. That guy. Well, the volume will be a double integral over this region D. And you then have two functions. One of them is on the top and one of them is on the bottom. And if you get it right, your volume will be positive. And if you get it wrong, your volume will be the right number, but negative. What's the easiest way to tell which of these is on the top and which of these is on the bottom? How could you tell which is the larger of the two?
G of x because it's concave down and 22 is bigger than 6.
That'll do. Right. So if I put this guy in here and I subtract this guy, we're good. Since this is a circle, would you agree it would be a good idea to do polar on it? Okay, we'll just live with that ugly R value. And this, take away this, what on earth does that get me? It gets me 16, take away 6x squared, take away 6y squared, or dr d theta, because we're going polar. And if you can, shouldn't you try and make your life as nice as possible by turning everybody into r and thetas, and in the simplest version that you can. Negative 6x squared, negative 6r squared is actually not that bad. What does that get you in polar?
Negative r squared.
How many?
6, sorry.
Yeah, you're right. There we go. Okay, so basically, can't I just do theta equals 0 to 2 pi of 1, and then do the 0 to the ugly square root value of 16r take away 16r cubed dr, and there we got our volume. So when you're trying to find the volume created by two surfaces, F and G, you make them equal to each other to find the region, the intersection of the region, because that's going to be your D that goes here. And then you find the big one, you take away the little one, and you get your answer. Now, if I'd got these back to front, wouldn't I be able to fix it? Wouldn't I just say, oh, minus 20, yep, plus 20, and a little note, reverse the order of integration or something. Just say, hey, I know I got them back to front. I seem to be picking circles a lot, but aren't circles kind of very common for some reason? A lot of times that's what you'd expect. Any questions?
How would you find the area like of a surface like in a given region?
You mean like a surface area question?
Yeah, I think so.
I'm trying to think of, because there's all sorts
Like
of
if you
different
go back
surface
to
areas.
the
Are we
like that one
talking
picture,
way back in the day? Or are we
like
talking
that
about
one
slopes?
picture that's like on the left there, like if you just wanted the area of that top little like
This-
circle bit.
This,
Yeah, that one.
right, so that we would call that a surface area, right? The question, I guess we need to find the right formula, because that's an early one, the kind you're talking about. You're not talking about Stokes' theorem, which is that horrible one that we did at the start. So these are all line integrals, don't want these. Right, so we're talking about, well, can I take out that e to the xy? Can we pretend that we had a nice function, one that's not going to make our brains blow up? Right, suppose that was the surface, right? And we have a region D, and let's say that region D was that circle, right? So it was x squared plus y squared equals 1. And we would like to know essentially the surface, right, integral of this guy here. So the guy that we're going to be using is this fella here. You know, we need a z in this fella, I guess. Well, my guy was z equals 2, so I guess I could rearrange it that way, but I don't want to. I got a circle. I need to pick one. My question is not as clean. It doesn't fit that situation. This is basically a surface area of a 3D shape. And then you're taking that 3D shape and you're only taking a piece of it based on that surface. So this is a different kind of one. It's a scalar function. No. Okay, let's just find one. That's the easiest way to do it. So I'm going to nip in and go to the past. And that way I can set up a question, because I've merged two kinds of surface areas into one. Because I'm thinking of Stokes' theorem, and I should be. Although that is a valid question, this is not Stokes' theorem. So this one is straight out of homework. Z is 16 plus x plus y squared, which is basically our surface, which is actually fine. I could have used that one. And the region D is given, well, let's just keep mine, x squared plus y squared plus 1. So that's actually going to work. And the formula for the area of the surface, which is the formula I was trying to find for our situation, is this one. There we go. The guy I was looking at, actually the guy I was looking at was this one. So I guess I just wasn't paying attention. So we are looking at a region which is a circle, radius 1, and it's going to meet up with this surface, and we want to find the area of that surface. So since it's a unit circle, I'm going to just do my standard, turn everybody into polar. And then you just take your surface formula and differentiate it with respect to x and square it. Then differentiate it with respect to y and square it, and add 1. Do a dA here. So it's going to be 0 to 2 pi, 0 to 1. The square root of 4y squared plus 2, r dr d theta. And then 0 to 2 pi, 0 to 1. That's 4 times r cot sine theta. So that's going to be 4 r squared sine square theta plus 2 times r dr d theta. Now, because I've got this horrible square root, because I just basically made that question up off the top of my head. Would you agree that this integral is pretty much dead now? Because there's not anything we can do to solve that. But can you pretend that if it was a well-designed question, you would have got something that might have looked more like this, right? Now, if that had been the question, right, if that was just missing, you would then split it as 1d theta. And then you do 0 to 1 of r, the square root of 4r squared plus 2 dr. And that guy comes out as 2 pi. And this guy would work with a u sub and you'd get your answer. So I'll pretend it's 42. And if it was 42, then this would be your answer. It's an annoying truism that many integrals are not solvable, right? There is no obvious way in which you can find this integral, right? It's just too ugly. If you had to solve this, what you would do is plug it into a computer and get it to estimate the answer, probably using Simpson's rule. But you do not get questions like that because the homework guys find ones where this happens, right? And so you get a question that does make sense. So that's the method that you would use and the formula that you would use. Didn't quite finish well because you're not meant to make up questions, at least I'm not meant to. They never work if I do it. Did that help?